This is how I got hit in the face way too many times for my liking while building a self-aiming robot using a Raspberry Pi and OpenCV to feed me Maltesers. I decided on a spring-loaded design for the launcher due to its simplicity and ease to try out several spring types and combinations. And as you can see, this led to varying levels of success. So after some trial and a lot of error, this is the final design. It uses a brass tube to house the holder and the spring. For the release mechanism, we're using an electric door latch with a couple of 3D printed mounts to hold the threaded rod. The threaded rod is there so we can adjust the amount of compression on the main spring, which will then determine the launch speed. Now that it's complete, it's time to test it out. I don't know how much damage this is going to do, but before I shoot it up myself, I'm going to test to see what happens. Three, two, one. That was probably uncalled for. Now, with all the fun and games over, I really need to get the speed of the projectile, which is required to calculate its trajectory. After several tests, the speed looks to be about 6 meters per second. Now with the launcher complete, we need to design a mechanism to aim it. To start with, we have this large base gear, which will be driven by a stepper motor to adjust the pan of the machine. Above that, we have the mount for the camera, which will do the aiming and tracking of the target. The tilt angle of the camera will be driven by another stepper motor driving this large gear on the left hand side. And then finally, we have the mount for the launcher in the middle here. The angle of the launcher will be adjusted by this gear on the right hand side and be driven by another stepper motor. Now that that's complete, it's time to do some 3D printing. And finally, after nearly 50 hours, my printer earned a well-deserved break and I could start with the assembly. Now that it's all built, we can go over the bit that I find most interesting. How does the thing actually work? The aiming will be all done using the camera and the Python module OpenCV. On startup, it'll read the first image, and then within that image, it'll use a Haar cascade to detect a face. Once the face has been detected, it'll send those coordinates to the object tracker, and then it'll start the video stream. Once the video stream is started, it'll draw a rectangle around those coordinates that have been sent to the object tracker. It'll then calculate roughly where the mouth sits within the face. It'll then use the center pixel of that mouth as its target. The stepper motors will be driven by the Adafruit motor driver boards to move the pan and the tilt of the camera until the center of the mouth is in the center of the screen. It then uses the distance sensor located right next to the camera to work out how far away the mouth is from the launcher. Once it's calculated that distance, it works out the angle the camera is at using the accelerometer mounted on top. Then using some trig, we can work out horizontal distance and vertical distance the mouth is away from the launcher. Once we have those distances and the velocity of the launcher, we can calculate the launch angle. The projectile motion Wikipedia page does a much better job explaining how this is calculated than what I could do. The stepper motor then drives the gear that adjusts the launcher until the accelerometer on top reads the required launch angle. Once the launcher has reached the required launch angle, it will then give you the option to launch. Launching will then be done by pressing the spacebar, which will then trigger the relay on the back. It is a 5-volt relay, but it's been modified to run off the 3.3 from the Raspberry Pi. The relay will then trigger the electric door latch, which will release the spring. Now all there is to do is to see if it actually works. Not quite there, but we're on our way. With it hitting lower than expected, that means the launch angle is too low. which would be caused by the projectile speed being slower than the value in the launch angle calculation. So let's input a slower speed value and see what happens in the next shot. Getting closer, just got to lower that speed value a little bit more. Now we are getting somewhere. So close to getting the speed value right, just need to lower it a touch this time. But now it has gotten closer, it's become obvious it's a little off to the left. Instead of checking every part and mounting hole to see what is out, I'm going to take the easy way out and just offset it in the code.
Where did that go?
Right there.
No.
Yeah. The speed value is on the money now. All that's left to do is to dial in that offset. Oh my god! It went in my mouth and come back out.
No, it didn't.
It did. Well, now I know the aiming is right. All there is to do is have another shot. After the trauma of being hit in the face so many times, I've started flinching every time I hear it trigger. Everything is operating correctly, but as Taylor Swift would say, it's me. I am the problem, it's me. I suppose it's time for another shot. After landing in my mouth and bouncing back out, surely on the next shot it would have to happen. To prove to myself that it wasn't just luck, I needed to make another shot. And plus, after all that hard work, I was hungry. I hope you enjoyed the video. If you have any questions or improvements I could make, comment them down below. If you want to see any more of my builds, subscribe. And as a thanks for your entertainment, here is a montage of some of my not so great shots. Whoa.
Where did that go?
In the neck again.
Did it go down your shirt?